Thank you, everyone, for being here. We'll just wait on. There's Ernest, and so yeah, my goal. I've just sort of noticed that I would like for all of us to kind of have a general understanding of maybe some of the things that I have to think about when I'm building these sites, as well as what the developers have to think about. But also because we're a remote company, because we work on the internet solely, I feel like this is just sort of a good thing for all of us to sort of understand on some level. It doesn't have to be crazy. I'm not expecting people to know how to forward ports or something silly like that. This is more just like, why do we do these things? What are some of the tools that have been used in the past? How do some of the things that developers use, transfer over to what everybody else is using, as well as, what are some of these tools and how they work. So, internet security. I would like to start talking about hacking and phreaking. Some of you may know what the term phreaking means. Some of you may not. Depends on if you're Gen X or if you're a millennial, really. But the people who taught me about internet security were two different developers that I worked with in tandem for many years. One is Don McKinnon. He was my main mentor as a developer. He is one of the chief leaders of the React community out here in Denver, and he has a client list that makes every person on the planet drool. He worked with Weird Al Yankovic. He worked with Sony Records. He worked with CNN. He worked with Reuters and Fox and Consumer Reports and all these huge other companies as a tech lead. Very smart guy, very intense to work with when I always talk about how his eyes would go all black when he would turn back into his original hacker self. He's a very smart guy. The other person is Chris McGowan, who is a developer who now works with Starbucks exclusively. Most of his people that he worked with were people at DARPA. And so talking about internet security with him, very intense experience as well. He was the type of person who, if we were in a coffee shop, would know who was trying to hack us, where they were in the coffee shop, and would take countermeasures to get the person to leave the room. That kind of hacker. So it was fun to learn from somebody like that for sure. And also makes you just kind of uncomfortably aware of all of the ways that people can hack things. But we're talking about the basics here. So let's start with the first thing. Let me go ahead and share my screen. Which one is it? Might be this one. I have two sets of Chrome going. Let's see here. Yep, this is the one. Everybody see the Wikipedia article on phreaking? Okay, so let's talk about phreaking. And I'll share all these links later on in some chat room. So phreaking, originally, people started figuring out that all of these complex systems, all these complex phone systems had these sort of back ends, all these back doors. And what they figured out is if you're going through all of these sort of menus when you call like AT&T or your electric company or something like that, that they could actually navigate these little menus that had been set up. If you want this, press 1. And they started doing things like pressing 0 to see if they could get to a different level. And all of a sudden people figured out that they could hit different number combinations and get into these sort of secret areas of menus that were part of these big companies' phone systems. Now, what they figured out as well is when you press a button on the phone, it submits a dial tone, a certain frequency. What they figured out is these frequencies triggered different things in these phone systems. And so they started building these little things called blue boxes. Now, this is, there's a lot more history around this, but I'm keeping this simple for right now. They invented these things called blue boxes, which became very popular. And a lot of the big tech people in our industry right now, all the boomer age big tech people, a lot of them did stuff like that. Let's see what people are saying in the chat here. Yep. So that's definitely a generational gap for sure. I'm an older millennial, so I'm the oldest millennial actually, as far as like years go. And my time is right after phreaking had pretty much just turned into hacking. And so if you're any older than me, you know about phreaking, you use phreaking, and phreaking was like a fun thing at one point, But then all of a sudden people figured out, you could get into advanced systems and really get deep into stuff, and people started getting into trouble. But this is where hacking comes in. This is how hacking really works. What people figured out with phreaking is not only could they type special numbers and get into secret parts of phone systems, you know, and at bigger companies, but they also figured out that they could use something that we in the hacker community call social engineering, which is they could maybe talk to the lowest person on a totem pole, and they could go, hey, what's the password? It's Jenny from accounts receivable, and the person on the lowest end of the totem pole goes, oh, okay, here you go. Here's the password to our secure server or whatever. Now, this is a basic tenet of hacking, and this is a very important thing to try and pay attention to for every person who works in the internet culture at all. When you're thinking about hacking, it is almost never a person typing furiously at the keyboard with Seth Green in some room and there's a van driving around. You know, it is literally never that. There's no such thing as somebody sitting here and, you know, hacking into something by just typing something. More often than not, it's something like social engineering, where they try and trick somebody, they try and spoof somebody into thinking that they're helping their own company, but in reality, they're probably helping somebody else. So we'll talk about more things down the line there, but that's sort of the basic philosophy of how hacking on the internet works. I can spend months or years trying to break into a server, or I could call one intern and ask them what the password is. And so, or send one email to one person where they think it's coming from a sysadmin or a tech person. In reality, it's coming from me, and I'm asking for really important stuff. Okay? So, and if anybody is interested in more of the legacy of hacking, I know Michael's on the line. He knows about this one. We're going to talk about 2600 magazine, which is referring to one of the first auto dialing, you know, systems that you could use to hack into stuff. This is a really fun magazine to write, and it's very anarchy oriented, but also really interesting in a lot of ways. It puts up a lot of ideas that people are coming up with on how to get further into the internet. So that's kind of like the basics of what hacking is, how it actually works. And let's move on to the most important thing when we talk about internet security is passwords. Now, how do passwords work? Why do we need a long, weird password? Why do we need password encryption in our databases? How should we share passwords with each other when we're talking about social engineering? Passwords work, and in a very simplistic way. Let me pull up the image here. Get my toolbar out of the way. Okay, so some of you may know about this comic, and it's been going around the internet for a while. It's an XKCD comic that talks about how passwords are sort of strong and why they don't believe that we should have like a password that's like 30 weird characters that are all over the place. And I can pretty well describe to you very quickly like why we need both a long password as well as a complicated password. When somebody hacks a password on a server, they use something called a dictionary, which is basically 8 billion passwords in a little text file, and it just runs through the text file and tries all 8 billion of those passwords, and then maybe tries to use them in combinations, which is why this comic sort of falls flat here. They're talking about how it takes a certain amount of time for a computer to either brute force or run a dictionary attack against something. A brute force attack is basically going A, no, okay, A, B, no, and then doing that 80 billion more times. So hopefully nobody in this room has a password that's all A's or all B's or like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And also common words. When somebody has a dictionary, whenever you hear about people leaking 2 billion passwords or 300 million passwords, that's a dictionary. That's something I can use to figure out if you use one of those passwords. So it's very important when somebody says that your password's been leaked to change it, because all of a sudden I go from every possible password in the world to this dictionary that can run through very quickly. A gigahertz is a very fast process. And if I have 1 billion passwords, I can do all of those passwords ran through trying to hack your system in a few seconds. So it's very important to think about things like length, but it's also very important to think about things like complicated passwords. Now, you know, whenever we use 1Pass, it's always like, here's a garbled thing of weird numbers and letters and characters. And the reasoning behind that is a dictionary is not going to have that. And brute forcing requires a lot of time, a lot of effort. And usually brute forcing, when you start, you go through A through Z and you go through 1 through 10. And a lot of those weird characters, the commas and the slashes and stuff, are not necessarily used because it just adds time and complexity. If your password is house, then I can just run my little algorithm to check all the letters and combinations, and all of a sudden I have your password. So that's kind of why we need like a long password. That's why we need a complicated password, and why it's very important when you hear that something's been leaked and your password is in the list. And I'll give you guys a tool after we're done here. Mozilla, the people who make Firefox, are one of the few companies that is truly trying to secure the internet and make it safe for everybody. And they have a great tool to make it so they can tell you if your password has been leaked. There are a lot of bad sites that will basically be like, has your password been leaked? Give us your password. What's your password? Has it been leaked? And then they'll just use it against you, you know. I mean, there's all kinds of tricks like that. And that's part of the social engineering thing I'm talking about. How hard is it for me to crack your password when I don't know any factors, as opposed to going, what's your password? Let me check and see if it's safe. You know, it's just very important. And that kind of brings me to things like sharing passwords and password encryption. Again, we have to think about the social engineering side of this stuff. I can make something super safe in technical terms, but if if somebody's talking to me and I get an email that's like, what's the password? Do I really know that that's the person who's talking to me? Do I really know that nobody else can intercept my email? That's one of those things. And like, and pretty much it comes down to, we want to make sure that we don't really have passwords going through normal channels. We don't really want to have things like API keys or special cryptographic stuff going in places where it opens up the possibility of a person being spoofed or a person being social engineered. When a client sends us a password, all of that is good, but email, unfortunately, you guys, is one of the biggest security leaks in the internet. It is so easy to spoof an email address. It is so easy to intercept an email. It is a crazy thing. It is one of the most open parts of the internet that still has a lot of issues with security. So when you email a password, it's just important to know that there's a lot of security holes in that, and it opens it up to somebody accidentally forwarding an email with a password and nobody here. But we're not talking about you guys who know this stuff. We're not talking about people who have good tech heads. It's people who may not necessarily think about that. And that's what we kind of have to think of when we're thinking about security. So last thing about passwords, which is another part of it. When we store passwords in our databases, it's never, oh, here's a column that says this is Ben's password. It's boat. Good job, Ben. You made a password that's 4 letters long and it's the word boat. What we do instead is we use something called hashing. And it's a form of cryptography. Basically, it's really simple. You have your password, which we see here, Apple. We add something called a salt, which is just a random amount of characters, and we put them together. So now we have a password that's even weirder. And then we use a hashing algorithm, which is just 8 billion different little computation things that take your password and the hash, combine them into a big piece of gobbledygook, this F53107B3 thing, and then that gets stored. Now, what we use on the server side is we use that little hash we put, Apple, the YRTZD here, and we use our algorithm, and we reverse engineer our algorithm, and we get the real password. And so when somebody puts their password into our site, we go, okay, they gave us Apple. Here's our little hash. We mix them together, mix them up. Does it make apple pie? No. Okay, well then the password doesn't work. That's how we work with things in our database, and why we don't have like crazy, or why when we go to the database and somebody goes, what's my password? I can't just go, oh, it's right here. And we shouldn't, because on the social engineering side, they've shown countless times that a developer has accidentally sent a file that has all these raw, we call it raw, it's a raw string, it's the word Apple. We send out this file that all of a sudden has all these passwords and people just use it. And when somebody hacks a database, they find out what this hash is, they find out how they use it, and then they just reverse engineer it. So it's important that we have our hashes kept secure. And what I usually do is I keep those hashes in a private file on the server that is only accessible by the most privileged user. And so all of that's a little complicated, maybe a little heady for some of you, but I just want to make sure that you guys sort of understand, like, there's a lot of things that go into creating passwords and using passwords that are not necessarily straightforward. And they're more on the assuming that somebody might have some maleficent intent. And that's not looking down on people. That's not assuming the worst in people. That's just trying to be safe when you deal with something that's a globally facing website. We're not thinking about us. We're thinking about somebody out there who wants to take advantage of the system and possibly get in. You know, we have sites like illuminations.bible that has payment information and Stripe accounts that could be used against those people if we don't take proper precautions. So, let's see. So those are kind of the big things on the front end I want to talk about, is like passwords and why we want to use a long password, and why phreaking and hacking sort of how they sort of work instead. I'd like to talk about another thing that developers use, and you may have heard of it, which is something called sanitization. Now, everybody see the Bobby Tables comic here? This is a really good example. In SQL, which is our database language, when you send something to our database asking for information, that query has to be very specific, and it has to have very specific characters in it. Because if it doesn't, if you send a query that maybe has like a colon or a tick mark or special programming language stuff, you can actually break the database. And you can actually make it so you can look at other stuff in the database. And that's where this Bobby Tables comic comes from. There's a story about Bobby Tables, which is Bobby drop tables. And what it basically means is I sent a query to the database from like a form. I had a form where I signed up for an email. But instead of calling myself Ben Fausch, I called myself Bobby drop tables : And what that did is it short-circuited the database's code and made it so I could get into the database and ask for whatever I wanted through this form. So developers, we have to do this thing called sanitization, which basically means removing all those special programming characters, the colons and the tick marks and the slashes and stuff like that, and sanitizing it so it's only letters and numbers and approved characters that won't break the code. But you can see how easy it is. If you have a complex system, if you have a lot of queries going back and forth, you have a lot of places that are asking for stuff and a lot of places that are sending stuff, if you accidentally don't sanitize something and a hacker finds it, that hacker has access to everything. And that's why we have to be careful when we're talking about sanitizing strings. Okay, so I'm trying to keep this one short. I'm trying to keep it light. So I'll love if anybody has any questions, but I'll finish up with kind of the basics of the internet and something that developers use called SSH. This is very similar, and this looks a little overly complicated here, this diagram where we're talking about private and public keys and initiation and, you know, all of these tech terms that may be interesting or confusing depending on who you are. But all this is how a developer connects to a server. There are two pieces on each side of each situation. We have the developer's keyboard over here, and we have the server over here. They both have private keys and public keys. Now, a private key is something that only you should know. A public key is something you can share with somebody. If I put my public key on the server now has my public key. I use my private key and my public key to make a new key. And the server uses their public key, or my public key and their private key, back and forth over and over again, using each other as sort of a completion of a sentence. You know, I start the sentence, I give you the other part of the sentence. And so when I start the sentence, now you can answer that other part of the sentence. That's how that works back and forth. It's known as symmetric encryption. Basically, everybody has half of the equation and we solve it together, and so therefore we can talk. If we can't solve it, blah. you can easily see how people started creating tactics to intercept that. What if I was able to get your public key and make you think you were connecting to my server? What if I did what's called IP spoofing, which is make it so you think that the address you're connecting to is my server, but in reality it's me. And then you send me all your information and I send you all mine, and we think, you think you're talking to the server, but you're talking to me. And all of a sudden I have every communication line that you had. There are a lot of techniques that people use to do this sort of thing, to get into servers. And so it's why I have to be very careful when I set up a server, and it's why I lock things down and why it takes so much time to set up a server. There's a lot of little pieces that have to go into play, and there are a lot of places where somebody could make little injections like this in all kinds of ways. It's very strategic. It's very much like hackers spend a lot of time doing social engineering, but they also spend a lot of time reading documentation, looking at bug reports. There was a bug in WordPress not too long ago that made it so you could go to any page on the site, and if you put a certain thing at the end of the URL, you could do anything to that website. And so for about a month in 2016, there were a million WordPress websites out there that people from Croatia and people from Pakistan and people from certain parts of South America had exploited to a level where you would go on a restaurant's website and it would say, owned by J-Rock or something ridiculous like that. So it's very important to make sure we stay up to date. It's why we have these care plans on all these websites. If a server goes out of date and all of a sudden there's a place on the server that somebody knows is a security risk, that server is vulnerable, and really it's a matter of time. So what do we do overall to sort of keep ourselves safe? What do we do overall to sort of keep ourselves thinking security minded when we're talking about internet security? Well, for one, first step's to not panic. When I talk to my in-laws who are very concerned about things like data breaches and hacking, there are 10,000 developers out there who have everybody's social security number, passwords, and all this stuff. But there are just as many, if not 10 times as many security people out there who are intercepting those people. They know where they're coming from. They know what their attacks look like. We have tools in place like WordFence that can blacklist those people when they're trying to get into stuff. There's always a data breach. There's always passwords being leaked. There's always important information out there that somebody has access to. But if they can do something with it, not so much, you guys. That's more like the end of Breaking Bad, where he's got the $500 million. But if he wanted to spend one of those dollars, everybody would know that it's him spending that stolen money. It's very similar in the internet. We know who's messing up. We know who's making things hard. And there's all kinds of measures to prevent them from doing that. Outside of that, just making sure that you know who you're talking to. When you get an email from a company, make sure that it's from the actual URL of the company and not some weird supporty, fakey sounding thing. Never click on a link if you don't know who it's from. Don't answer a phone call if you don't know exactly who it's from. There's a lot of spoofing out there these days, and things like Twilio. I could set up a Twilio account today and call everybody 1,000 times a day if I wanted to. There's a lot of mischievery out there. And so make sure you know who you're talking to. Don't necessarily open and answer things that are from somewhat untrusted sources. Verify what's going on when you're talking with people. And then also make sure that when you share important information that it's in a trusted channel. Public forums and chat rooms and email and stuff, they're very big, they're very big security holes. So I tend to try and use tools that are sponsored by places like Mozilla, just because they're putting the effort into stuff like that. I was going to talk about AES 256, but I feel like that might be a little heady. So I'll just share for anybody who feels brave and wants to get into really hardcore cryptography, I will share this link. This is probably the most in-depth way to learn about AES. AES, you guys, is what we use to keep the internet safe. It is a form of encryption that takes billions of years to solve, but it is not random. So if we don't take proper security measures in other places, you can still break AES pretty easily. And actually, there is a bill right now. I don't know the exact status of it, but it's going through legislature where they're trying to actually put a pinhole in AES, and that's an intense thing. We'll have to work with that as it comes and see what we do about the internet security. But every time you see HTTPS on a website, that's AES in action. It uses a very, very complicated matrix-based round key, insane. Like I've read this article like 50 times and I'm still confused by like 2/3 of the way through. It's just a very complicated system of mixing and mashing. But you can guarantee that it is the most safe way to work with the internet and keep things secure as of right now. Because we don't have supercomputers that can break it yet. When we do, we'll have to come up with a new one. So I hope I didn't lose everybody. I know that some of this stuff was pretty heady and it might be a little bit more codey than people would like, but I'd like to just sort of, talk about these things with internet security and kind of get them on people's radars. You are safe. Everything is cool. We're not going to be, attacked by some, unknown source with, knock on wood. But we do want to make sure that we think about some of these things from the mind of like a social engineering standpoint or a hacking standpoint. People have tools that they try to use to break into things, and we need to be safe. So that's kind of the basics, you guys. Does anybody have any sort of questions about any of this stuff, or does anybody have anything in internet security that they may have heard or maybe want to discuss a little bit? It looks like you got Jason raising his hand. I'm just trying to make sure everybody else is turned off. So Jason, what do you got?
I was just going to throw out real quick. One of the points that you brought up is talking about sharing passwords with password managers and sending stuff using like Mozilla Send or some other encrypted form of sending stuff. And I just real quick wanted to reinforce that by one of the gigs that I worked at. We had that exact situation happen where we had a staging site set up, and the site had a generic admin username and password set up so that all the developers and all the PMs could log in and see it. And that got shared in an email. And eventually the site went live, and that email thread got shared with a lot of people, and eventually made its way to people who were testing inside the company. And it just kept going further and further away from us. And eventually somebody realized, hey, you guys just copied the staging database to production. I can log in with this staging user and be an admin on the production site. And they started wreaking havoc.
Yep.
And not really intentionally, they didn't realize that they were logged in as a true admin user. Misunderstanding, thankfully, but my point is, it was completely innocuous. Nobody individually made a malicious decision. Nobody said, hey, let's go mess things up. It was purely a sequence of people saying, let me just forward this email on, and hey, check it out. There's this username and password you can use to log in. But just to reinforce the point of like, there was no hacker. There was nobody sitting at a command prompt with, black screen and green text pounding on a keyboard furiously. It was just password in the email and stuff like that. So,
and it speaks to the social engineering side of hacking and how really that's really the thing to worry about. Again, the amount of effort it would take me to hack into a server is days to weeks. The amount of effort it takes me to call somebody at the company and pretend to be a guy, put a fake mustache on and get a trench coat with two other guys who look like me and walk in there. And like the amount of effort it takes me to do that is so much less. And that's usually what people are trying to do. There was a big data breach that I had to do a write-up on for one of our clients earlier, or I guess in 2019. And, they tried to make it seem in all the reports like it was some huge, hacky, like somebody got into our database and somebody broke everything. But in reality, what it was a disgruntled ex-developer who had administrative privileges to all these different things. And they were just able to get into the servers and do whatever they want and get databases. So, yeah, at the root of all of this, you guys, it's people more than it is anything else. It's process, it's systems, it's philosophies. It's a lot more of that sort of thing. It's just keeping yourself aware and smart about working with the internet. And, you know, again, not having fear. I know who has my info.